Thanks for your interest in human-centered development and usability engineering that I want to talk within the next 45 minutes approximately about. The title also says you should use those methods and methodologies as a driver of medical product innovation. If you want to learn more, please feel free to check out the website www.use-ing.de and allow me to show you what we are doing over there. As Carl already said, we are based in the beautiful south of Germany, basically in the heart of Europe, in Stuttgart. And from there on, I'm leading a team of engineers, psychologists, and designers to optimize the human-machine interaction between medical devices and their users. So our services basically follow the different methods that you find in usability engineering or human factors engineering. So we offer expert analysis regarding user interface specifications or ergonomic guidelines, heuristic evaluations or cognitive walkthroughs. We also support with our designers within the ideation and concept phases. We actually also realize prototypes. And at the final end of this never-ending circle, we also perform user evaluations that you might know as formative or summative usability tests, which is crucial for the medical devices. One crucial point that we are specialized in is the recruitment of medical test persons. As you might know, as a manufacturer, it's always difficult to get representative users from the medical field, but you need them to show that your interfaces, your human-machine interaction is safe and effective. Yeah. So let's jump right into our topic. I want to show you today that usability engineering on one hand is crucial for the safety of medical devices, but also on the other hand, that it could be a big source for innovation. And when we are talking about innovation, the question is always, how can we innovate in a human-centered way? So you might all know this cartoon. The story is as old as mankind. You have your customer and you as a product manager or as an innovation manager aim for to best understand your customer and to best translate the customer's needs into a final product. But you see, within the process, within the way, you have several opinions, you have several stakeholders, people interacting, information gets lost, misinterpreted, and a lot of times you end up with something totally different than the user wanted. So the question is, how can we best come from the user's mind or the customer's mind to a great product that the customer and user always wanted to use? And the crucial problem is a lot of times that the customer not even knows what he wants. So how could we address that challenge? So, I mean, the answer is usability or human factors engineering for our medical devices. And the good thing is that we already have quite some good standards, as Carl already mentioned, the IEC 62366, for example, or the FDA equivalent that is helping us or even forcing us to talk to the users and to integrate them into our product development process. But as most of the times with medical standards, the focus is on effective and safe use. Okay, this is like the must that we need. But I also want to show you today that there's another branch. So the user research innovation potential that is lying within this usability engineering framework. So when we identify user needs and translate them into adequate technical system requirements and are also able to specify them in a good and right way, we have some innovation potential that is just lying there on the way within our product development process. So it's crucial to integrate real users, representative users within our product development process. And if we do so, we can interlink engineering, design, and marketing and achieve great user experience, comfort, or even joy of use, which most of the time still is something of the smartphone or the electronics industry, but we should also aim for that within our medical devices. They should give us joy while we use them, not only be effective and safe, of course. So how could we do that? Theoretically speaking, it's quite clear what we should do. So let me give you an example. You have a great idea, maybe engineering driven, a new emergency call system that you maybe want to do an app for seniors that might allow them after a fall to call for emergency for emergency service in a quick and easy way. So if you have that idea, you should first run an acceptance test. You should confront real users, for example, seniors. What do they think about it? And this is a real example. So we did this. We addressed a pool of senior users, and they told us, we don't use smartphones. We don't like them. And there's a big stigma with those old-fashioned emergency call buttons that are hanging around our neck. So why could we not use jewelry to call for help? So there's innovation potential coming up from the users. So you could transform that into scribble sketches. You build 3D models. You get into the heads of the users, more into the workflows by building up user stories before you define the operating principles. Maybe you start with some wireframes and you go back to your users. Maybe you run a formative test. Maybe you run a focus group review. So it's along the way you start to work more on your prototypes. You detail them more, maybe a cut, print first jewelries that you could transform into a high fidelity prototype, and go back with those devices again to the users to see what they are thinking about. Maybe you run various formative test rounds before you end up with a final usability summative test. And as you see, you end up with a nice innovative product. It's a jewelry meant for emergency call for seniors, and they don't have to be stigmatized. They enjoy to wear it. They feel proud to wear it. And maybe you still have a side app, but you see the way I started is quite different from the way I finished. So why don't we always do it like this? But I mean, the reasons are obvious. We have time pressure. We have 1,000 things to do. We heard a lot from other experts today. So usability engineering is not the only thing that we have to do. We have a lot of regulatory hints that we have to follow. And a lot of time there's a lack of expertise. So what I want to give you today is a little guideline maybe to improve those things. We call it the usability engineering process for medical devices, and it breaks the more complex usability processes a little down that you find in the FDA and the IEC 62366 documentations. So the core of everything is the use specification. There we should start, but as you see, there are some errors going to the right and the left. The use specification is leading us into the world of requirements engineering and also risk management, which, of course, we are in the medical field. It's crucial to have risk management in mind. But those interfaces to those worlds, give us a mirror effect. And after thinking about those methods in there, it comes all back to the user interface design, and we should run various evaluation rounds, first formative and end up with a summative user evaluation round. So let's jump into this process and and look a little bit more into the details. First, into the use specification. So in this phase of the usability engineering process, it's crucial to run good user research and analyze your context of use. So to elaborate your use specification, you have to make sure that the intended use, of course, as a basis for every medical product is defined properly, and you have a good knowledge of the intended use, the medical indications, and so on. But the usability engineering is adding more to it, more to the intended use to become the use specification. So at this point, it's crucial to specify and analyze also the intended user profiles and specify and analyze your use environments. So who is doing what in which environment? And the answer to the what you find within the task analysis that is giving you the main and subtasks. And the main and subtasks are like a kickoff for your risk management, the risk management where you need your use scenarios for to identify your hazard-related use scenarios. So this is the left branch, but on the other hand, it's crucial to not only have technical requirements in your medical device development process, but also to add the user needs into the requirements process. And to identify the user needs, this is also something that is happening in the use specification. So what kind of methods could you use at this early phase to identify those topics that you have to address in the use specification? I try to categorize them into basically 3 branches. So you have the category of trying something, you have the category of asking, and you have the category of observing. So some examples of methods for you on this slide. A developer role play, for example, a good way to try in early phases and raise your level of empathy, better understand your user. This is key in this phase. You also have simulation techniques. For example, in the gerontechnology sector, you have age simulation suits that you could use as a developer to better feel how it is to be old, and to derive user needs from that. Second category, asking. Of course, we have interviews. We have the opportunity to run surveys, interrogations, one-on-one, or maybe also online in big numbers. And as I already showed you before, we have the possibility to run focus groups. Last but not least, in the observe section, we have video and audio recordings for very detailed user research. You could use the think aloud technique, and to really elaborate on it, note here on that point, it's not always reasonable to do that, but in very special occasions, it could also be interesting to run eye tracking analysis. I can also show you more on that topic in the next slides. So let's jump into the methods. An example about the try category, the developer role play, is meant to run a familiar use scenario with an internal company group. So the advantages is it's very cost effective. It does not take much time or money. You just gather your fellow developer colleagues, and you should always do that as a developer. Try to experience your product, put it on, put your electrodes on, maybe try to sit on the seat where the anesthetist is sitting while treating a patient, or take the spot of the patient. How does it feel to lie on over there on the table in the operation room? Yeah. But of course, the disadvantage is you are your team, you're primed, you always all think into the same direction. So it's not the only thing you could and should do. You're lacking the real representative users. But it's a good starting point, and you should always start like that. A hint on that, combine it with a think aloud technique. So meaning that you verbalize your ideas throughout this role play. Always say what you feel, what you like, what might be pain points on the way. So this is an example for the trying sector. The asking sector, a good method is the focus group. So the focus group is a discussion of user behavior and expectations of your product in a group. And as a recommendation from our experiences, try to have a good group size. We recommend to have between 5 and 7 people. If you have way more, it's nearly impossible to control this group of people. If you have way less, then you don't achieve what you want to achieve with the focus group. You want to have different opinions and also want to have a discussion within the group. We recommend a duration of 90 minutes, maximum 120 minutes. After it gets tiring. So the advantage is you have a lot of different views in a short period of time. You can discuss and have different inputs. The disadvantage is you have to control the group dynamics very well. There are always dominant persons that dominate the opinion creation within the group, and you have intimidating other people that might be shy, that don't try to express their opinions, and you have to animate them to also get their insights. Yeah. So how could those user innovation sessions look like? You maybe invite a bigger group, a smaller group, depending on your session. You might use a focus group, you might use a persona, you might use a context interview, and the outcome could be user needs that could be translated in requirements for your process. Yeah, and later on, you translate your user needs into user requirements, and finally specify your user interfaces based on those user needs and user requirements. So to finish the 3 categories, the observe category, one good example is a video analysis. As you see here on the right side in a time frame, we have a surgery on the open heart. So a lot of things are happening. A lot of users, medical stuff is going in, is going out. The patient is moved. We have a lot of devices being brought into the operation room, being carried out. So it's very complex workflows, and the video analyzers give you the chance to make a detailed analysis, to rerun it and look at details. On the low side, the disadvantages, of course, are that you have very time-consuming evaluation. You have a lot of video material that you have to review. And of course, keep in mind that you always have the challenge of data protection. Anonymization is crucial in this point. Yeah. So to complete it, another technique that I already mentioned is the eye tracking analysis. And as you see here, the good thing is that you don't only have video data, but you have circles of attention, as you see on this video. So you see where the user's attention is going. You can even have more detailed insights and better understand them, why they are looking at this button, or why are they looking at this section of the display. Can I lead and guide my attention as I intended to as a designer? So you get way better insight. Of course, you require experts and expert material for it, so you should not always use something like this. So pick the right methods at the right time in your process and try to better understand your customer. As to complete that image, something that we frequently run is mobile eye tracking analysis with mobile eye tracking glasses, really to analyze the graphical user faces. An example given here of a vital signs monitor. When an alarm is popping up, does it catch the user's attention? This is a question that you can answer with those glasses. Let's go to the second phase. You remember, we finished now our use specification. Next on the usability engineering way would be the user requirements engineering. So we use the user research to identify our user needs, but now we want to translate them into our system requirements and end up with the user interface specification that we need for the usability engineering file, for example. So what are user needs? It's on that point crucial to understand that user needs are not like random expressions, something that people or medical professionals just set within the context of use, and you take this like a law, carry it back home into your development department and said, but this physician said that it should be like this and this, and you try to give them exactly what he needs. No, you have to translate those expressions into user needs. User needs are necessary for a user group to achieve a desired objective within the context of use. And they are always related to that context of use and justify what happens in this context. The FDA wants you to prove that your user needs are met within the design control process. So this is a crucial point for the FDA regulation. But the user needs are not related to a system under development. Keep in mind that user needs facilitate the solution neutral elaboration of solutions and provide opportunities for innovation. So it's not literally that's something that was set, but it has to be transformed. Remember Henry Ford, as he always said, if I had asked my customers what they wanted, they would have said a faster horse. And this is not what we want. So we need user research. We need to observe closely, but then we have to translate. And how could we translate? I give you an example. We start at the context of use, for example, an electrosurgical scalpel to cut tissue. So the user need would be one user need during surgery. So context of use, the surgeon must know if the scalpel is energized to perform a tissue cut. Okay, so this is crucial for him. So now we have this user need that we can transform into a system requirement that could be maybe written down like this. The system must display the current energization state of the scalpel to the user. Okay, and then we specify our user interface. The HF generator has a status LED indicator that shows the energization status, maybe a green LED to indicate, so now electricity is running, or maybe a red one that's saying, okay, no electricity is running. So maybe this LED would do the job, but on that point, there also might be room for innovation. So you could get fancy here. You could try to go other ways, maybe AR glasses showing the status within a head-up display. So I don't know if that makes sense. It has to be validated, of course, and it has to be brought in line with all the other technical requirements that we have. But you maybe understand that if you come up with this methodology, it opens up new ways to think and new ways to improve your user interfaces. So this was it with the requirements branch. You remember on the right branch of our process. Jumping into the left, crucial, something that always is related to medical devices, the use-related risk assessment. So I called it here use-related risk assessment, since this is the branch addressed by the usability engineering. But you already heard a lot. My fellow speaker before was talking about software risk management, which besides other technical risks are crucial for our medical device. But focusing on the user, there are a lot of risks that have the root cause within the operation, the control of our system through the user. And this is what we are focusing on here in the use-related risk assessment. We need to elaborate hazard-related use scenarios, and we have to perform a use-related hazard and risk analysis. And how could that look like? Remember, we are coming from the use specification, jumping into the left branch of risk management. And our objective goal is to derive use scenarios and perform that risk assessment. Later on, leading us to risk control measures that we have to give as an input for our user interface design. So use-related risk assessment usually follows a different approach than technical risk assessments. You probably all know the FMEA methodology, and probably most of you are using it for your risk management or risk assessment. We personally recommend to perform another methodology, the preliminary hazard analysis, PHA, in combination with the PCA method instead of an FMEA. Why do I recommend that? The thing is that use-related risk is coming from control of our interfaces. So the root cause is always a use error, a so-called use error. And this is quite different than the crunching of numbers that we are doing in the FMEA. So simply, it's not impossible to also run a use-related FMEA, but it's easier to run a preliminary hazard analysis. I will show it to you later. It is crucial to pay close attention to the definition of hazard-related use scenarios during the use-related risk assessment, since it is the basis for the selection of the test cases for our summative user interface evaluation. So within the summative user interface evaluation, maybe we want to run a usability test to validate the safe and effective use. But we have to pick use scenarios that we translate into test cases. And this is the point in the process where we do it. The hazard-related use scenarios are defined within our use-related risk assessment. Okay, but still, risk assessment can also be a source for innovation. So how could a use-related risk assessment look like? I was mentioning the PCA methodology before. PCA is standing for perception, cognition, and action. So basically, you have your tasks all set in the use scenario. You run a task analysis. And after you have your task, you jump even more into detail. You break down your subtasks into perception, cognition, and action step. So let me give you an example. Maybe I have a device, a high-frequency generator. Let's stick to that example for electrosurgical interventions. So first we have to connect an instrument to the generator. So we sit down and do like a cognitive walkthrough. What is the user perceiving? What is he doing? And what mental processes, cognitive processes are running? So the user is touching, feeling the cable. He is plugging it into our socket, which would be the action, but he has to know which cable has to go into which socket, which is crucial. And if we break down that process like this, we can then think, okay, what is happening if the user does not know where this plug has to go? What is happening if he's putting it into the wrong socket? So there we end up with potential use problems and use errors, and those guys we need for the use-related risk assessment. Then we take those use errors and we put it into the preliminary hazard analysis. Basically a risk table similar to the one that you were seeing before in the talk, but a little different. So in the software risk assessment, there's a lot of focus on the probability. The problem with usability is that most of the time we don't know the probability for a use error. What is the probability that someone is taking a plug and putting it into the wrong socket? If you are running a good post-market surveillance, you might have data on that, and you might give us some numbers here. But if you're in an early phase, starting with your product, you basically don't have this knowledge. And this is where the standard is saying, okay, don't focus on the probability, but just focus on the severity. Okay, and based on this severity, ask yourself, would the result be an injury or impairment that needs to be treated by a medical professional intervention? Okay, would it require professional medical intervention, or even worse, of course? And if the answer is yes, it would be a hazard-related use scenario, and it should automatically go into your summative user interface evaluation. Okay, so this is the way how you pick your hazard-related use scenarios that build later the test cases. What do we need to test user interfaces? Of course, we need prototypes. And this is also a crucial part that a lot of research and development departments do not pay enough attention to. So for every evaluation, we need prototypes, but those prototypes not always have to be really fancy, elaborated. It could be very basic. Any kind of prototype is always good to run a formative test. So just to give you a small impression, how could you build physical human-machine interface prototypes? Nowadays, we are blessed with the world of 3D printers. So we can be very fast in printing out physical elements, control elements, and give them to users, run small first internal formative test, maybe invite some representative users and try to learn more about the way they operate with our user interfaces. And of course, in the digital world, the graphical user interfaces, we have various options, good software to create wireframes, to create click dummies that we should use in very early stages. So finally, we have our user requirements. We had the risk assessment. We have our prototypes. So it's time to evaluate our prototypes. And in usability engineering, it's crucial to run a circle, always building new prototypes, updating maybe your risk assessment, updating your requirements engineering, performing new formative user interface evaluations until you reach a point that all risks are controlled and you are happy with your product. Then you go to the last phase, the summative user interface evaluation. And just to give you an impression of a formative user interface evaluation, the objective is to optimize your human-machine interaction and to improve the user interfaces. So they should be performed as early as possible within the product development. Methods that could be used are cognitive walkthroughs, heuristic evaluations, and also in that early phases, usability tests could be run with real users. So in a cognitive walkthrough, you take an expert and he is basically following the workflow and evaluating your user interfaces regarding strengths and weaknesses. He often uses heuristics for this. So could be interaction principles, could be guidelines that you could use as a kind of checklist to evaluate the interfaces and to improve them. And finally, if you're, as I said, happy with the product and all risks are controlled, you end up with the summative user interface and evaluation. And the objective is to prove that your interfaces are effective and, of course, safe to use. The tools and method that you need are a good test person recruiting. Keep that in mind, depending on where you want to release your medical device. The FDA, the US FDA is special. For example, the FDA requires you to test with US citizens, but all of them require to recruit representative users. So really medical professionals that have experience in the field. Make sure that you simulate the user environment if necessary. And a lot of times you have to use usability labs facilities. Like, for example, we also run in Stuttgart, and you have here some impressions, the observing room and the room where the surgeon is performing those usability simulations. And you have to create protocols and create a usability evaluation report from that. The outcome is a good usability engineering file that is fulfilling the regulatory requirements of the IEC 62366 or the corresponding FDA guidance. So I'm approaching the end of my talk. I hope you can take something away with you. And to facilitate that, I want to stress the most important points of my talk again. So the use specification is the starting point for usability and human factors engineering. Make sure to research your users to have an empirical basis for your product design. Requirements engineering, don't forget to add user needs to your stakeholder requirements and translate them into reasonable user interface specifications. Don't forget to run use-related risk assessments. Pay close attention to assess your use-related risk correctly. Integrate a usability and human factors expert into your risk management process. This is crucial. User interface design. Don't forget to constantly design prototypes along your process. You need them for your evaluations. And we recommend to run 2 to 3 formative user interface evaluations along the product development process. Pay close attention to select your hazard-related use scenarios based on profound risk assessment and translate them into representative test cases. Okay, so thank you very much for the attention. If you want to learn more, I can recommend you our webinars or on-site seminars that we are running in cooperation with Professor Pfeffer from the Furtwangen University. If you want to learn more, please go to www.using.de/seminare. And of course, don't hesitate to get in touch with me if I can support or answer your questions. You have my contact details here. You find me on LinkedIn, or feel free to use this email address and my number. Thank you very much for your attention.
Thank you, Dr. Janny. Thank you very much. We already have some interesting questions here in the chat, and I'll shoot them straight away. The first one, is it recommended to start the product development only after the prototype is successfully evaluated? And I guess you're strongly hinting towards this, aren't you?
Yes. As I stressed, the earlier you are able to create prototypes, the better it is. So, but one crucial thing is you should not be stopped, or should not stop your product development process because you think that you don't have a good enough prototype. So anything could be used as a prototype, a simple sketch, a clay model that you could form could be used for it. So I hope I addressed the question.
I think you did. So if I get you correctly, if you have a prototype, you should evaluate it, and that should be the input for your user needs. If you don't have a prototype, that shouldn't prevent you from starting thinking about the use context.
Exactly. And a lot of people perform formative user interface evaluations on the way. Even if just 2 developers are sitting together discussing about sketches, this is a formative user interface evaluation. Document it, write it down, and add it to your usability engineering file. It's valuable.
Are you of the opinion that people are starting to elicit their user needs a bit too early without evaluating the context the way you describe it?
A lot of people don't take the time in the early phase to really get out there, observe people, talk to people in the medical field. That's true. And if you don't do that, spend that little time, you will regret it on the way because you're lacking information for decisions.
Great. I have another question for you here. Is the purpose of 62366 mainly usability contributing to safety, or is it about designing a user-friendly medical device in general?
In the old version, there was a first version of 62366 from the year 2007. At that point, it was not divided yet. With the 2015 version, you have a /1 part, 62366/1 part, this part is the standard, and this is obligatory, basically focusing on effectiveness and safety. You have a technical report, the /2 part of 62366. Little people know about it. I highly recommend to take a look into this. And this guideline is not an obligatory standard, but this is giving you a lot of information about a higher user experience, optimizing effective and satisfying user interaction. So the answer is /1, focusing on effectiveness and safety, regulatory, obligatory, and /2, focusing on the user experience, but it's not a must.
That is a spot on answer. Then I have a trick question for you here from the chat. What about products that doesn't have a user interface, like an automated data analysis tool? Do they still need to provide good usability? Are they judged according to the 62366? How should one address this?
I would say that there hardly is no medical device that has no user interfaces. Think of users maybe in a different way. Someone would have to maybe run maintenance on also such a product. So the guy that is running maintenance on that product is a user of your product. So basically you should optimize it for that user too. So the answer would be basically all medical devices have user interfaces, and you should focus on those users.
Great. So last but not least, then, here is a question that I think concerns a lot of people, and I think you have one or two things to say about it. How shall I differentiate between misuse errors and usability errors? Are they different things, or is it the same thing? How shall I classify them? How shall I deal with them?
That's a good thing that's always coming up in discussion. So as I mentioned, the core for everything is the intended use that you have to define very well. So within that phase, you should also define what is misuse of your product. Since the standard is telling you have to keep in mind reasonably occurring use errors, but which are not in the scope of your intended use, but which could be performed by users using your product in a wrong way. But you should strictly try to define and separate a misuse from the reasonably foreseeable misuse. Yeah, so try to separate those things, and then follow this path and define what is a use error and what is not a use error. So misuse is only relevant for you if it's reasonably foreseeable. Okay, if people are doing things that are way out of scope with your medical device, you're not obliged to treat those use errors in your usability engineering documentation. So first things first, define it as narrow as you can, as clear as you can within the use specification, within the intended use.
Thank you very much. So you mentioned in your slide deck here that sometimes the medical device developer needs to get hold of a usability expert. I assume you are that expert. Am I right?
Exactly. This is what we and the using company is providing. All of the people there are usability experts that are running such expert analyses like heuristics evaluations, cognitive walkthroughs, etc.
That sounds great. So everybody, whenever you have a question or a problem that needs to be addressed in the domain of usability engineering, Dr. Janny is the man to reach out to. You can find his email address here in the last slide and his telephone number. Thank you very much, Dr. Janny. It was a pleasure having you here.
Thank you very much for your questions and for having me.